All right, so let's do an example, another example. Um, so the data below is showing the cost of the airfare and the distance traveled to each definition from an airport in Baltimore, Maryland. So we're starting in Baltimore, Maryland. What's the distance and the cost of flying to all these other different cities? The question is, what's the explanatory and what's the response variable? And it matters here. The explanatory is what is the cause? No, I don't want to say cause because we're not talking about causation here. What's the explanation? And we're going to usually say, well, the explanation is going to be the distance, right? The further the distance, we think that would have a correlation with the airfare. Okay? So our explanatory variable is going to be the distance. And our response variable, or dependent variable, y, is going to be the airfare. We think that distance, a change in distance might cause a change in airfare. Just intuitively about what we know about the world. Create a scatter plot with technology. Okay, we're going to try to copy and paste this data. And if it works, oh my word. If it works, great. And if it doesn't, we'll have to manually do it. I don't know what is happening today over here, but it really wants to go to my next page. Oh my goodness. All right, I'm just going to try to do it, but we might have to copy it down. And again, this is one of the downsides. You might have to drag these over, kind of just like I did right there. Plot this. All right. All right. We can copy it manually. It's okay. Sometimes you can also copy and paste it to a different program like Excel. That'll make things a little bit easier as well. Or you can do it the old-fashioned way and get some good typing practice in. Oops. Be very careful that you're inputting the data correctly. I wonder what was happening with Microsoft Edge, my PDF reader. That was causing it to kind of move around so interestingly as well. Again, usually you should be able to just copy and paste this over, but sometimes weird things can happen. Man, these are cheap flights. I wonder how old this data is from. These flights are looking good. All right, let's highlight all of them. And two variable analysis. Give us our scatter plot. Oh, I'm not going to jump to the line. There's our scatter plot. You can see the distance traveled by a plane on the bottom, and the cost of airfare in dollars is our y-axis. So we have our scatter plot, and again, if we had to export it, you could use this little arrow right here, either copy it to your clipboard or export it as a picture. All right, so what else does it want us to do? Create a scatter plot using technology. Done. What's the correlation between the airfare and the distance of the flight? Well, roughly linear correlation so far. So yeah, roughly linear. Positive, the slope is positive, it's going up. And it looks medium, medium strong, etc. Or if you don't want to guess, show statistics. R is 0.6953. So not as strong as the last one, but it's positive. It's mostly linear. And it's moderately strong. All right. Again, how can we describe that in words? As x increases, right? What is x? X is our explanatory variable, the distance. As the distance of the flight increases, right? That's x. The y value will also increase. That's what positive means. The cost of the flight also increases on average. Cost of the flight is y. Distance the flight travels is x. That is one way of describing this. You could also include the explanation about how strong the correlation is as well. But this is the heart of what this question's asking. What is the coefficient of determination? Remember, the coefficient of determination, that's that r squared value. Okay, so r squared is going to be 0.6953 squared, which is going to be about, let's find my cursor, 0.6953 squared, which is going to be about 48.34%. Again, if r is lower, r squared is also going to be lower here. And to interpret it, we'll interpret it just like we did before. The coefficient of determination is just saying what percent of the variation in the y's is explained by the variation in the x's. So this says about 40% of the variation of the y's, so variation in the airfare, can be explained by variation in the distance of the flight. That's all it wants here. And graphically, we could kind of look at this as well, right? It just wants us to look at this scatter plot over here and say, okay, what percent of this variation, like what percent of like these things jumping away from this line, if we had a line that we'll talk about in the future, how many of these differences can be explained by the airfare and how many of these differences cannot be explained by the airfare. So about 48% of this data can be explained by the distance. 48% of the differences in cost can be explained by the distance traveled by the flight. All right, so yeah, maybe like this one down here, this one down here, and this one down here can't be explained, and there's maybe a couple ones that partially can't be explained and stuff like that. Okay, and that's one way of tying these terms together.